Hi everybody, so this section is on systems of equations, more of them, and then we're also going to do a test for functions on a graph using something called the vertical line test. So we've looked at very similar situations like this before. Here we have a system of equations in this first example. R sub e times t sub e equals r sub w t sub w. And then we have some other equations like r sub e equals 200, r sub w equals 250, and t sub e plus t sub w equals 9. And our job is to find t sub e and t sub w. So what I like to do with these is I kind of like to focus on the equation that includes all of our variables, and that would be this one right here. Now, I already have some information here. I have that RE equals 200 and I have RW equals 250. That's important. The two unknowns, really what we need to do is we need to do some substitutions into this one that I've circled so that we only have one unknown that we can then solve for. Now, what I might do is focus in on TE or TW, but I'm going to focus on TE to start. So I'm going to go ahead and solve this TE plus TW equals 9 for T sub E. So to do that, I'm going to subtract T sub W from each side. And this is what I would get. So now what that allows me to do is to plug in 9 minus T sub W for T sub E. And then that's going to let me solve for T sub W in this equation that I've circled. So what I'm going to do now is I'm going to substitute all the information that I know into the circled equation. So I know that R sub E equals 200. I know that T sub E is 9 minus T sub W. I'm getting that from over here. And I've got that equal to RW, which is 250, times T sub W. And it's okay for me to leave this T sub W because the whole point is that I've written out an equation that only has one unknown. In this case, it's T sub W. So now it's just a matter of solving this equation. I'm going to use the distributive property here. Add 200 T sub W to each side. Divide each side by 450. And that leaves me T sub W equals 4. And now to find T sub E, all I have to do is go back up to my original equation sets up here. I'm going to actually change my color here so I can look at this focus at this point. I'm going to take this one and bring it down to solve for T sub E. So I'm just going to, again, substitute 4 for T sub W. And I get T sub E is equal to 5. So I've done it. I've solved for T sub W. I've solved for T sub E. The only extra step that's different than maybe what we did last time is that you might have to solve one of these for one of the variables like we did up here with T sub E. Let's take a look at this second one. Similar kind of idea. What I'm going to do is I'm going to focus in on my T sub 1 plus T sub 2. And I'm going to solve for T sub 1. I could solve just as easily have solved for T sub 2. That would be fine. Okay. And now I'm going to do my substitutions. So R sub 1 is 30. T sub 1 is 10 minus T sub 2 plus R sub 2 we're going to put 40 in for, and T sub 2 we're going to leave as T sub 2 equal to 360. And now all I have to do, since I have an equation that just includes T sub 2, is solve for T sub 2. So I'm going to distribute as I was doing before. All right. combine like terms here. Subtract 300 from each side. And divide by 10. And so what we get is t sub 2 is equal, oops, I made a mistake there. This actually should be a positive 60, because I'm doing 360 minus 300, which would make this a positive 6. So actually t sub 2 should be a positive 6. Sorry about that, but there it is. T sub 2 is positive 6. And now what I'm going to do to solve for t sub 1 is take that little equation that I had right here from the beginning, and I'm just going to do t sub 1 equals 10 minus 6, substituting that for t sub 2, and we get t sub 1 is equal to 4. And so there we have it. We've solved for t sub 1 and t sub 2. So that's the first part, just a little bit more advanced work on systems of equations. The second part is going to be doing something called a vertical line test to determine whether a graph is a function or not, represents a function or not. So if you go to page 364 in your textbook, you'll notice that there's a page that looks like what I have right here. I took that right out. And there's 3 different graphs here. And the way that the vertical line test works, there's a description of the vertical line test in your book. Essentially what you're going to do is that you're going to take a vertical line and use it to determine if the graph is a function or not. And the way that you're going to do that is that you take your vertical line and you move it across the x-axis, essentially from left to right, like I'm doing here on the screen. If this particular graph passes the vertical line test, what that means is that at every point that you move it across, it's only at some point touching one point within that graphed section. So if I take A, I'm going to demonstrate this here. I'm moving it across, and this one is actually touching, it looks like 3 points at once, which means that it's failed the vertical line test, which means that this is not the graph of a function. So this is failed the vertical line test. It's touching more than 1 point. So it has failed the vertical line test. So we would say that this one is not a function. There it is. Not a function for A. Let's take a look at B and try to follow that same idea. So I'm going to try the vertical line test with B, and I'm moving it across. And as I keep going, it appears that at all points along here, it's only touching 1 point on this curve. So because of that, this has passed the vertical line test, and this is, in fact, a function. So yes, a function. Let's try C. With C, we're going to follow the same procedure, and right off the bat, this one fails the vertical line test because all along here it's touching 2 points. So this has failed the vertical line test and therefore not a function. Why don't you go ahead and take a look at the practice problems and see how you do.